Right. Today our topic is to learn about the modulus functions. Modulus functions, right. When you're discussing about modulus functions, we need to discuss two types of modulus functions. The first one is fx total modulus, and the second one we need to understand is f of modulus of x function. So, and these are the two types of it we need to understand in this topic today, right? Basically, let's try to understand. We need to know about what is the idea of this modulus function. Idea of the modulus function. That's the topic we need to work out for this one. And before we, prior to the start of the definitions on any kind of like extensions based on these modulus functions, we should know what is the idea of this modulus function. For example, if you get modulus of 3, the answer we know it's 3. If I ask you to find the modulus of minus 3, that one also
it's 3.
3. We know that irrespective from the sign, we consider the largeness or the magnitude of the function is called the modulus. So you can say simply, irrespective from sign, the largeness is explained by the modulus. Okay, now we'll come up with the definition of the modulus. How do you get this modulus and how do you define a modulus function? That's a fact we need to understand. So if you define modulus of fx, pretty simply, you can write the same thing. If I want to find modulus of 3, we wrote 3 over here. We can write the same thing instead of this modulus. Modulus 3, we can just write 3 if. Under which condition? If this is a positive number, positive O equals to 0, if it is greater than or equals to 0. If this, the term inside the modulus is a greater value, greater than 0 value, or it's a positive value, you can write the same thing itself, right? Then if it is a minus 3, Pute, how to make 3? If you put another minus over here, minus 3, it's turned up to 3. So if it is a minus value, we can put a minus in front of this, and if you write it, you get that one. Under which condition? If fx is less than 0. If fx is less than 0, we can put a minus in front of, and if you write it, you get that. That is the definition of this modulus function. That is quite important for us to understand the situations based on this definition, because in the next level of simplifications, we should know this fact. We have to be very clearly understand this definition of a modulus function, because it's directly related to solving modulus equations, right? Initially, we'll try to understand about the modulus graphs. Modulus graphs, right? Initially, I'm trying to work out with the modulus comes to the total function graph. Right, okay. We'll start from a very basic graph, how to draw it today. So we know that if I just from a simple example, let's try to explain this matter today. X equals to modulus of x today. X equals to modulus of x. I will get some simple figures. I will get just make it a little bit of like to reduce the confusion. I just make it little bit, I will add certain term for this, like my 2x, modulus of 2x graph. Then I'll get some x graph, x values over here. I get minus 3, minus 2, minus 1, 0, 1, 2, and 3. Then you can get the y values. Modulus of 2 into minus 3 is minus 6. Modulus of minus 6 is plus 6. 2 into minus 2 is minus 4. Modulus of minus 4 is 4. 2, 0, 2, 4, 6. If you plot this graph, it would be just like this. 1, 2, 3, 0, -1, -2, -3. Turn up to 2, 4, 6. This is y values, right? 0, it's -3, 6. It's here. -2, 4. It's here. -2, it's here. It's like this, this, and this. So it comes like this way around. Right. This is the modulus graph of y equals to 2x. So all the situations we can draw this graph and to get this in this way. Just like marking the coordinates are really hard to mark the graphs over here. Then simply how do you draw this graph? That's a fact we need to understand. From the same example, let's try to understand this situation. If you want to draw this graph, initially draw the graph without the modulus, but 2x. If you draw y equals to 2x graph, it's just like this. You can see it's a traveling through 0 with this kind of a graph. Is that? Then what happened here is this is a negative part of it. What happened to this negative part? It was reflected to the positive side. Therefore, you can draw modulus of 2x graph like this. Then x equals to and y. This is the modulus graph of that. That is the initial way of drawing it. You have to reflect this negative part, just like I will draw it the different color, then you can understand it clearly. Then this part, this negative part, transfer to the positive side. That's how it comes with this. Right? Okay, that's a way of getting this fact. Right. Okay. Then when you come up with this kind of a graph, suppose that if it is, sorry, we'll use different color, sorry, the blue color we just generally we use, y equals to 2x plus 3, right? Then if you draw this graph, it's just like this. If you draw it, it's a straight line somewhere over here. This coordinate is 3, meet with the x-axis, y-axis means x equals to 0 is 3, and this is -3 over 2. Meet with the x-axis means y equals to, meet with the x-axis means y equals to 0. By making it, you can take -3 over 2. Now, from this graph, it doesn't make an impact on the positive y values because the modulus, so we want to draw this graph. So initially, we need to draw y equals to 2x plus 3. That means up to here, it doesn't make an impact. No problem at all. This is 3 and this is -3 over 2. Then what you need to do is we need to reflect this negative side. So this is the point you come across with it. This negative side below x-axis 1 should reflect to the positive side. Then you can draw the graph like this way. That's a way of getting the answer for this kind of a question. That's a idea of making the modulus graph for entire function, right? Okay, let's go a little bit further. Right. Next situation, let's try to draw it. Y equals to modulus of x squared plus x minus 6. Initially, we need to draw y equals to x squared plus x minus 6 graph. I'm not going in detail of how to draw this graph, means like this graph, that one you should learn from the AS level work. So here the factors are plus 3 and x, plus 3 and minus 2, it should be minus 3 and plus 2. So the graph goes like this, and it's like this, sorry. It's like this, and this coordinate is -6, right? Then our problem is the negative part of the graph, negative part of the y values, because the modulus comes to the total of it. That means we are concerning about this part of the graph. The positive part of the graph doesn't make any impact to your final answer, right? Okay. Now let's draw this. Then if you draw the modulus graph, it's just like this. So yeah, so here it's y and x and 2 and 3. So up to this point, it doesn't make an impact. No problem at all. But when you draw this negative part of the graph, what you need to do is we need to reflect it. So it goes like this way around. Whereas this minus 6 turn up to how much? It's turn up to plus 6. That is the way of drawing this modulus of graph for this. Okay. Let's go ahead with another example. Right. Then if it is y equals to modulus of x plus 3, x minus 2, x minus 4, right? Initially, we need to draw y equals to x plus 3, x minus 2, x minus 4 without modulus, right? If you just draw it, you can understand the graph like this. X plus 3 means it's minus 3. It intersected minus 3. Minus 2 means it intersected 2 and 4. Then these are the intersections over here. And the meet the y-axis means when x equals to 0, it's turned up to 24. Then you can see the graph goes like this and it goes like this. Right. Then what you need to draw is 2 and 4 and minus 3. Then this positive part of the graph doesn't make any impact. It's 24. And this part also not an issue at all. Then when you draw this positive part of the graph, negative part of the graph, it's just like this. And it goes like this. I'm referring to this part of the graph and this part of the graph. That is the point we need to understand when you're drawing these modulus graphs. Okay, let's go ahead with one more example, a couple of examples with these modulus graphs. Yeah, if you want to draw modulus of 1 over x graph, initially we need to draw y equals to x graph. So if you draw it, it's like this. Right. Then if you draw the modulus graph, you can see it doesn't make impact on the positive part of the graph. Only the impact comes with this negative part of the graph. It's just this part of it. It should be reflected over here. In this case, we need to mark axis of asymptotes over here. X equals to 0. Yeah, that is the way of understanding this kind of a graph. Right. I'll make a little bit of advanced of these graphs. If it is y equals to modulus of sine x graph, modulus of sine x graph. I think you can remember how we drew the sine x graph. It's like this. You can draw to infinity. This side even. Just like this. So this is pi by 2 and this is pi and this is 3 pi by 2 and this is 2 pi, 5 pi by 2 and 6 pi, sorry 3 pi, so on it comes, minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi, so on it comes. But then this maximum value is plus 1 and the minimum value is minus 1. Okay. This is just y equals to sine x graph. Right. Then if you draw this modulus graph, so it doesn't make impact on this positive part of the graph. It doesn't make impact over here. And here also, it doesn't make a problem with this. Only the issue comes with this negative part of the graph, these parts, these ones. What happened to them? They will just turn in this way. That's a way of understanding this type of a graph. Right, okay. So that is the basic idea of drawing kind of modulus graphs for, sorry, this is the modulus part of it, y equals to sub sine x, right, okay. Then, yeah, the next one, I'll make another one more graph, is based on this. If it is y equals to modulus of 2x plus 3 and x minus 2, sorry, x minus 4, right. I think initially we need to draw 2x plus 3 over x minus 4. I hope you can remember how we drew this graph. If you are not familiar, just go to the previous video in this topic. This is, I think, the functions, the prior topic. We were discussing how to draw this graph. I will just draw this. So you can say the vertical axis of asymptote I can make this equals to 0, and you can write it as x equals to 4. And horizontal axis of asymptote is coefficient of x divided by coefficient of x over here. This is y equals to 2. Then intersection with the x-axis. Intersection with the x-axis means y equals to 0. If it is my y equals to 0, it's turned up to minus 3 over 2. Meeting the y-axis means when x equals to 0, that is minus 3 over 4. Right. So the graph is just like this. Hope you can remember how we drew this graph in our previous video. So now I'm just going to draw the modulus part of it. Y equals to 2 and x equals to 4. This is just like this up to here. It's over here. Minus 3 over 2. Now our doubt is what is the extension comes for this part of the graph. So this goes, this reflection goes to 3 over 4. 3 over 4 minus 3 over 4 is here. It's turned up to plus 3 over 4 and it goes like this. That's the shape of the graph where we should know. That's a simple way of drawing this kind of a graph. I have not drawn to the scale, that is why it just come like this. But if you draw it perfectly, scale can draw it much accurate graph, but they ask you to write the sketch of the graph. So writing up to this extent is enough. That is the basic of this drawing. Y equals to modulus of fx, whole modulus of whole fx. That comes out that. Right. Now the next topic is, now we already just learned how to find this graph. Modulus of f of modulus whole thing, modulus of whole fx graph. Right. That's a topic we already learned up to now. Right. Now the next extension is we should know how to draw this graph, modulus of fx graph. So how to draw y equals to f modulus of x graph. That is the graph we should know. Initially, we'll come up with this graph with a y equals to 2 modulus of x plus 1 graph. The transforming, that means for all negative values also you get the positive answers. That's what you mean, right? This is pretty simple. This graph, we will initially the same thing we need to draw with it. Just draw y equals to 2x plus 1 graph. That is, it comes like this. 1 and minus 1 over 2. Right? Okay. When you draw this graph, other one, it's just like this. Remember this logic. When you come up with, if the whole thing modulus comes up to the x-axis, we can draw the negative part of the x-axis should be reflected to the positive side. Right. When you come up to the modulus comes to the only the variable x or whatever the variable, if it is in this format, you have to draw up to y graph only, but the y-axis only one, not a y graph, y-axis only, and you have to scrub this part with it. You have to scrub this part. This part has to be scrubbed. Whatever the graph, doesn't matter how complex the graph is, nothing to worry, you just scrub this graph and reflects this positive side to the negative side. That's the way of drawing this graph. What you need to do, we can draw up to the y-axis, erase this negative part of it, erase this negative part, then reflect this positive side to the negative side. This would be your final answer. Let's go ahead with another example and try to make sure what is this, what is the shape of this graph, right? Okay. If it is y equals to 3x minus 4, right? Modulus, sorry, I'll just do it nicely. It's 3 modulus of x. 3 modulus of x graph, right? It's just like this. But initially, we need to draw y equals to 3x minus 4 graph. Minus 4 and 4 over 3, right? Then what you need to draw is, we can draw up to, it doesn't matter, you can get the negative y values, it doesn't make impact. Only thing is that to draw up to this, minus 4. So this negative part, this part of the graph, I justify, draw different color, then it will be clear for you. This part of the graph is erased. This part of the graph is erased. Then you reflect this positive side to the negative side. Then you can draw just like this. That's a way of drawing when the modulus comes to only the variable. It's plus, yeah, minus 4 over 3. That's a way of drawing this graph, right? Okay. Let's go to another example. Right. Y equals to modulus of x squared plus modulus of x minus 6. Right. Initially, we need to draw y equals to x squared plus x minus 6 graph. Graphing these ones should be, you should know how to draw it. 3 and this is 2. So minimum comes to this side. We know that minimum comes to this side. So here the value is minus 6, right? Then when you draw this modulus graph, up to here, it doesn't make an impact. Minus 6 and 2. Then what happened here? This negative part of the graph is erased, which I'm drawing with the red color, should be erased. And this positive side be reflects to this side. So it comes like this. Minus 6. Sorry, minus 2. I made a mistake. So minus 2. That's a way of drawing this graph, right? We'll go ahead with another example as well. Right. If it is a graph like this, y equals to modulus of x squared minus modulus of x minus 6. The same graph with a negative value over here. So initially we need to draw y equals to x squared minus x minus 6. So if you just draw this, you can say it's 3 and this is minus 2. The minimum comes to this side, just like this, where this value is minus 6. Then when you draw this graph, 3 and minus 6, this part of the graph should be erased. Others were just fine. So you can draw it's like this. And this, the same thing, should be reflected from y-axis. It's a graph like this. That's a way of drawing this graph, right? Okay. Right. Let's go to another example. It's just a graph like this. y equals to modulus of x squared. We'll get minus 7 modulus of x plus 12. Yeah, let's draw this. Initially, what you need to draw is we need to draw y equals to x squared minus 7x plus 12. If you just draw this, you can see the intersections are 3 and 4. So the graph is just like this. This is 12. Then when you draw the modulus graph, this part of the graph will remain as it is, 3 and 4, and this is 12, and the same thing should be reflected to the positive side, sorry, to the negative side, just like this. Minus 3 and minus 4. That's a way of drawing this graph. Right. Okay. Let's go to another example. Yeah, if it comes with y equals to modulus of x squared plus 7 modulus of x plus 12. So when you are drawing this, initially we did draw y equals to x squared plus 7x plus 12. The graph is like this. Minus 3 and minus 4, and this is 12. This is the important point of the graph. That means, Pute, when you draw this graph, I told you whatever the negative side of the graph is complex, nothing to worry. We have to scrap that part. Therefore, this total graph should be scrapped. And we just draw like this up to 12. Then for the negative side, it like this. That's all. So whatever the complexity is, it doesn't matter. So you have to ignore that. You have to erase that and to draw the reflection for the positive side to the negative side only. That is the entire graph of drawing with the modulus. I just draw modulus of x squared plus 7 modulus of x plus 12 is a graph for that. Right. That's a way of getting this type of a graph. Right. We'll draw one more graph with that. So y equals to, if we to draw sine modulus of x graph. So we have already learned how to draw this. Initially, we had to draw y equals to sine x graph. It's like this. Right. Then when you draw the modulus graph, it's just like this. The modulus mark should be, sorry, the negative part should be scrubbed and it should be reflected. That's a way of drawing this modulus graph for that. Is the So just refer with the initial total modulus sine x graph and what is the difference between this. Those are the facts you should learn when you draw in this modulus graphs. That's a way of drawing a modulus graph. So